Okay, so we got this student standing on the top of the cliff. We're given the height of the cliff is 50 meters. That's the vertical displacement of the stone. I made it negative. Why did we make it negative? Because down is negative, up is positive. And our sign conventions are like that. This initial velocity, they tell us in the problem that the stone is thrown how? Horizontally, which means the initial velocity is perfectly in the x direction. If the initial velocity is perfectly in the x direction, what is the initial y velocity? 0. Okay, so what else did we say? X velocity remains constant, right? And that assumes no air resistance. In real life, the x velocity would decrease because of air resistance. But we always assume there's no friction of any sort, no air resistance. So Vx stays constant. What's another way of saying that? The x acceleration is 0. There is no x acceleration, and that's the reason that the 4 kinematics reduce to one equation. What's the one equation for the x direction? X displacement equals v times t. You take the x velocity, multiply by time. And by the way, where does that equation come from? All that equation is it's the definition of velocity. Velocity is displacement over time. That's all it is, with no acceleration, assuming no acceleration. Okay, so what else? The y acceleration. Now what happens to the stone in the y direction as the stone falls? The velocity is going to get bigger. So like if we look at the stone right here, we have our x velocity, Vx is still 18, but now we have a y velocity, Vy. And then if we go from here to here, now the y velocity is going to be what? Even bigger. The y velocity increases. Okay? So, first question. So we're solving for two things here. The first thing is 1, how long after being released does the stone strike the beach? And then the second thing is, with what speed and angle of impact does the stone land? Okay, so solving number 1, you got to make a decision. For all these, throughout the whole chapter, what's the decision you have to make? Am I going to answer this question using the x direction, or am I going to answer this question using the y direction? You're never, ever, ever going to take x data and y data and use x and y in the same equation. You're either going to be plugging pure x data into an equation or pure y data, because x and y are separate. All right, so are we going to figure this out using x direction or y direction? The y direction. We don't have enough information in the x. All we know about the x direction is that the x velocity is 18 and that doesn't change. That's all we know. Okay, so we're going to go to the y direction. So I'm going to use the first motion equation, y equals 1/2 g t squared plus vy initial t. So that's the first kinematic. I wrote it for the y direction. What is the initial y velocity? 0, so that goes away. So now you're left with this, which we can solve for t. So t will be square root 2y over g, and now we plug numbers in. 2 times negative 50, right? The vertical displacement's negative because it went down, and then gravity is negative 9.8. The negatives cancel, and we get a time of 3.19 seconds. The time in the air is 3.19. Okay. Second question. Find the speed and angle of impact. Okay, so when the stone lands, is it going to be traveling perfectly x like that? No. Is the stone going to be traveling perfectly y like that? No. How will the stone hit the ground? And by the way, guys, the answer to this question is not 0. I've heard that because when the stone hits the ground, the velocity is 0. That's not what we mean. We mean like the split second before impact. So the split second before the stone hits the ground, how is it traveling? It's traveling like that, right? It's traveling at an angle, okay? So now let's show the components. The components are, so we'll do this in red. This velocity has an x component and a y component, okay? Now, we already know, let me shrink this up. I need some. We already know what the x component is. What is this x velocity? It's 18 because it's constant, doesn't change. Okay, now we got to solve for this y velocity. What is the y velocity of the stone at the moment it hits the ground? Well, how do we find it? With a what? With a kinematic. You're using a motion equation. So, okay, so finding this y velocity here. There's different ways you can do it. I think the easiest way would be to go Vy final equals Vy initial plus GT. That's the third kinematic on the list of kinematics. All right, what was Vy initial? 0. So Vy final is going to be G times T, so that's negative 9.8. And we now have the time, 3.19 seconds. So Vy final is negative. Hey man, should it come out negative? Yeah. Why should this answer come out negative? Because which way does Vy point? Down. So it makes sense that it comes out negative. So it comes out as negative 31.305 meter per second. And now we can solve the problem. So we go boom. So this is no longer a question mark. This is now 31.305. So now what do we do? Oh, and yeah, negative. Put negative. Hey, if you're on a diagram like this, I mean, this arrow shows the direction. So, do you have to put the negative right there? I would say no, because you're already showing that it's down. All right, so how do we get this answer? We're looking for this black vector right here, right? That's the total velocity of the stone when it hits the ground. So what do we do to get that black vector? Pythagorean Theorem, which I'm not going to show. Everybody can do it. A squared plus b squared equals c squared. If you do Pythagorean Theorem correctly, you get 36.1 meters per second, but that's only half the answer. What's the other half of the answer? The angle, right? Vectors always have a direction, and they even say right here, they say what angle. So how do we get the angle? To solve for that angle, you go tangent inverse, opposite over adjacent, so 31.305 over 18, and then this gives an angle of 60 degrees. So here's the final answer. The stone hits the ground right here at 36.1 meter per second, 60 degrees what? 60 degrees southeast. Are you going to say southeast here? No. That's a very common thing, guys. Look, north, south, west, east. It's like, oh, that's southeast. Is going into the ground, is that southeast? No. Kids do that all the time. What's the best way to describe this angle? Below the horizontal. You could just say below the horizontal. Definitely not southeast. Yo.
Why did you do tangent 31.3 over 18? Could you do inverse tangent of 50 over 57 point? Or couldn't you just use the?
Oh, use this right here?
Yeah.
Oh no, because you know what? It's doing that. You're treating the path as if it were a straight line. It's not a straight line. It's a parabola. That's a good question. Look, look, because kids will, I've heard that many times, like, you got these measurements here, this is 50 meters right here, you solve for that, but look, this is not a straight line hypotenuse. The hypotenuse is like, it's a hyperbola, it's a parabola.